This video is a lesson preview for 4.3 notes. In this video, we will learn how to identify critical points from the graph of the derivative and how to identify local maximums and minimums based on the graph of the derivative. This problem tells us that the derivative f prime of x is graphed below. So I would begin just by labeling the graph as the derivative function. Let's look at the questions that we were asked. First, A, is f of c a local minimum or maximum? B, is f of x a decreasing function? Since we're interested in part A of f of c, let's look at c. We'd want to remember that this graph is actually the graph of the derivative. So we know that f prime at c, since it crosses the x-axis at c, the derivative at c must be equal to 0. In terms of a local minimum or a local maximum, for a local minimum we'd think of something maybe like this, a local maximum something like this. And this would be the point of the local min, this would be the point of the local max, and all of these would be for the original function f of x. Okay, just an example of each. So briefly, for a local minimum, we know the behavior of the graph is decreasing before the minimum point and increasing after. The maximum is increasing before the maximum point and then decreasing after. So this is how we would identify whether it was a local min and a local max if we were given the graph of the original. But we in this problem were given the graph of the derivative. Let's zoom into these pictures to help us better understand what to look for the graph of the derivative, and then I think we'll see clearly whether this is a local min or a local max. Looking at our sketch of this local minimum, I've picked a few points and drawn the tangent line to the point in dotted orange. So here we see the tangent line to this point is this, here's tangent line to this point is this. And let's focus on what's happening before the minimum. Okay. Any point that I picked before the minimum, there is one characteristic about the tangent line and the slope of that tangent line. Since the function was decreasing before the minimum, the slopes of all of these tangent lines would be negative. And since the function was then increasing after the minimum, the slopes of any point that I pick, the slopes of the tangent lines for any point that I pick after the maximum would be positive because the function is increasing here. What this means is that we can translate the idea of when we have a minimum based on the slopes of the tangent lines before and after. F of x then would have a local minimum if the derivative f of c has a local minimum if the derivative at c is equal to 0, and then for values before c, the derivative is negative for some time before, and if the derivative is then positive for values greater than c. Okay. Let's look at the behavior of a local maximum next. Here we have our local maximum at c, and we see that the behavior of the graph is such that it is increasing for values before c, which would yield slopes of the tangent lines all being positive. So the derivative is always positive valued before c. Then, after the maximum at c, the function starts to decrease, which would make the slopes of these tangent lines all negative. So for values of x greater than c, the derivative is negative valued. F of c is a local maximum if the derivative at c equals 0, and then for values of x less than c, so for values before our local maximum, we have the derivative is positive valued. For values after our local maximum, we would have the derivative is negative valued. Let's go back to the graph of the derivative and apply this information. From this graph, we do see that we have the derivative at c equals 0. For values before c, the derivative, which is this graph, is always positive valued. This means the original function was increasing before c. Then for values after c, x values after c, the derivative function was always negative valued. that means the original function after c was then decreasing. This is just our basic sketch of f of x, so this is our point C, and from this graph we see that that means f of c is a local maximum. The next question asks us, is f of x a decreasing function? The graph that was drawn is a decreasing function, but this graph represents the derivative. We've sketched a graph of the original function. We see it as increasing and then decreasing, so it is not a strictly decreasing function, so we would say no.